Today we are going to discuss this problem. This problem is basically on the topic of center of mass, and this is very like this problem is given in nearly all the books. This type of problem you will find in I think nearly all the J books or wherever this chapter is given. So basically, what is this question? We will move towards the question. There are two person on the boat. This is person A and this is person B. Now this boat is on the water, and suppose now this both of this person, they want to come to the midpoint, this point. Now what we want to find, what should be the displacement of the boat. What should be the displacement of the boat? That means, see, first of all, what we can say is we can take this boat and both the person as a system, whole thing as a system. This is boat, there are two person, this is A, this is B, this is person A, this is person B. We can take this as a whole, as a system. Now we know that there is no external force on this system. If this boat is on the water, if we will not consider viscous force, that means there is no external force on this system, no external horizontal force. External horizontal force on the system in horizontal is 0. That means if there is no external horizontal force on this system, so in horizontal direction I can say that, suppose the center of mass of this whole system lies somewhere here. The center of mass of this whole system lies somewhere here. So if the external force is 0 on horizontal direction, that means there is no acceleration of center of mass. There cannot be any acceleration of center of mass in horizontal direction. This will be 0. Why? Because we know that sum of all the external forces on system is equals to mass of system into acceleration of center of mass. If this is 0, that means acceleration of center of mass is 0. Now in starting, this whole system is in rest, that means UCOM is 0. Now if I will calculate if we know that initial velocity is 0, acceleration is 0, that means what we can say about the displacement. Displacement of center of mass is given by UCM into T plus half ACOM into T square. So if both of them are 0, that means I can say that displacement of center of mass will be 0. Displacement of center of mass is 0. If we can use this one to find what will be the displacement of, because person A is heavier, weight of person A is 60 kg, weight of person B is 30 kg. If both of them come to the midpoint, the center of mass, and like if you want the center of mass to be in the same place, the boat will move it should move. The center of mass will start moving if the boat will not move. So that means the boat should move. Now we have to find that in which direction the boat will move. So for that purpose, what we can say is we can take any direction. If we don't know where the boat moves, we can say that the boat is moving to the right. Suppose the boat moves right by X, center of mass location is not changed. Okay, so displacement of center of mass is 0. What is the formula for displacement of center of mass? This is m1 delta r1 plus m2 delta r2 plus m3 delta r3 plus m3 delta r3 divided by m1 m2 m3. Here m1 m2 m3, all of them are person A, person B and boat. So like if the boat moves by X and both of them comes to midpoint, that means the person A is moving by 2 meter on the right side, person B is moving 2 meter on the left side with respect to boat. They are moving with respect to boat, and the boat is moving X to right. We have considered it X to right. But if our answer comes in negative, that means the boat is going to left side. So what will be the total displacement if the boat moves by x distance? Now if I am drawing the diagram, if the boat moves by x distance, it moves here by x distance on the right, it moves by x distance on the right. That means what we can say is the person here, the person on the left side, this is person A, this is person B, and this person, they are both are coming to the midpoint, like they are here, both of them are traveling 2 meter, and this person B is traveling 2 meter to left. So what is the displacement of A, total displacement of A? This will be the displacement of boat x plus 2. So I can write this as x plus 2 I cap, like in positive x direction person A is moving. What is the displacement of person B? So displacement of person B, total displacement, I can write as x on the right side and then B comes to left side by 2 meter. That means x minus 2 I cap. And what is the displacement of boat? R boat, delta R boat, this is equals to x I cap. Now we know the displacement of all the three objects. Now I can apply this formula. I can apply this formula and I will get the answer. So displacement of center of mass is 0 is equals to what is mass of the boat? Mass of the boat they have given as 80 kg. So this is 80 kg into x I cap plus, for person A if I will write, so mass of person A is 60 kg and mass of person B is 30 kg. So for person A I can write as 60 kg into, what is the displacement of A? It is x plus 2 I cap, and then what is the weight of B? 30, and displacement is x minus 2 I cap divided by 80 plus 60 plus 30 kg. Now you can say 0 is equals to 80x plus 60x plus 120 plus 30x minus 60. So what we will get, 0 is equals to 80 plus 60 is 140, 170 x plus, here what we will get, 60 plus 60 is equals to 0. So I will get x is equals to 6 minus 6 by 17 and 6 by 17 meters. So let me first check the calculations. Yes, so this is moving by person is 60 kg weight, person B 30. So x plus 2 for A, x minus 2 I cap for B, because B is moving 2 meter on the left side of the boat. So x minus 2 I cap, displacement of boat is x I cap. Yeah, so everything is correct. 80x, 60x plus 120 plus 30x minus 60. So what we are getting here is 170x plus 60x. So yeah, we are getting x as negative. That means the boat is moving to the left. The boat moves to left by 6 by 17 meters.